In this video, we're just going to look at what an ellipse is. We've already looked at the other three conic sections, the circle, the hyperbola, and then the parabola as well. So I want to talk about an ellipse. What is an ellipse? So in plain terms, look at F1 and F2. This looks similar to a circle, right? But we understand that a circle is where the distance from a point called the center is the same. Okay, so if I was to draw a circle here, in fact, let me just draw one for the sake of our demonstration. I will bring a compass just there, and then we'll draw our circle. Okay, so let me just do that for us. Okay, so that's what a circle is. When you compare this against what we have as an ellipse, there's a difference. So the distance from that point called the center to any point on a circle is the same, and we call that the radius. Okay, so this is different. Now when you look at the ellipse, the distance from the center to that point, and then again the distance from this point to that point, we can clearly see that there is actually a difference, right? Okay, so there is a difference. So the major axis and the minor axis are, we can actually see that it extends differently. So what then defines an ellipse? So an ellipse is defined by the property that if you look at the 2 points that we are calling the foci, okay, because there are 2 focus points, so the foci, when you look at F1 and F2, the distance to any point on the ellipse, the sum of the distances is actually a constant. What that implies is, if you look at P itself in this case, that point there on an ellipse, measuring a distance to F1, we call it D1, and then also we look at distance to F2, we call it D2. The sum is a constant. That principle applies to any point on an ellipse. So again, if we come up with another point, let's say this point, and then we measure to F1 and then again measure to F2. Okay, by definition, that is also equally going to be a distance. If we are to actually call it D3, D4, so D3 plus D4 equally would also be equal to the constant. That's basically what an ellipse is. Okay, so plainly I've actually written down for you to say a set of all points in the plane whose the sum of the distances to the points F1 and F2 is a constant. So this is another form of a definition: a set of all points in the plane, the sum of whose distances from 2 fixed points is a constant. Okay, now if I take you back to this diagram, I want you to know that a line that passes through F1 and F2 is called the focal axis. Now the focal axis cuts the ellipse on 2 points, okay, on 2 points that we call the vertices. Okay, that's one thing. So I'm calling that the focal axis. Okay, so the focal axis passes through the 2 let me say the foci. It passes through the foci and then intersects the ellipse at 2 points. Now the funny part is now where we again talk about a line again that cuts through like that. We call it the major axis, okay, because we have now what we're also going to call the minor axis. Okay, so the longer one is the major axis, the shorter one is the minor. Okay, so it's possible to have an ellipse that is actually in this direction, where the major axis is the y-axis and then the minor is the x-axis. That's also possible. Now that we understand what an ellipse is, we want now to come up with the equation that we're going to be using when it comes to an ellipse. Okay, so let's make some assumptions here to just help us. So let's take again that central point to be the center, to be at the origin 0, 0, and then let's say that foci f1 and f2 are at points. If the distance from that point is negative c to the other direction, so that would mean f1 is at negative c, 0, and then f2 on the other hand, since it's on the positive side of x-axis, that is going to be c, 0. Okay, and then what do we expect to be the vertices? So let's say vertices are these points, right? And of course they are also the equal distance from that point, so therefore this is going to be, if we say a to the left, negative a, 0, that is going to be a, 0, since it's the positive direction. Okay, these are a few things that we can actually take note of. Okay, you know what a is. A is a distance to the vertices, c is the distance to the foci. Okay, in this case, in this scenario, what else do we look at now? Okay, so to derive the equation from our definition of what an ellipse is, we've said the distance from any arbitrary point on the ellipse is actually the summation of the distance to the 2 points is a constant. So if we measure, say for example, the distance from f1 to p, okay, that distance plus the distance from p again to another point f2, the idea there is going to be a constant, and that constant happens to be equivalent to the length from this point to that point. So the length of the major axis, the length of the major axis, basically that cuts okay, the length from the two vertices along the major axis. In this case, since we are saying going to one side it's a, 0, even the other side it's also a. Now the fact that it's on the negative, we are calling it negative a. So if we add the two, of course ignoring the signs, we understand that the distance along the x is going to be 2a, okay, which is our constant in this basic scenario. Okay, now that we've understood that, we can actually even use the formula for measuring the distance, and then of course we can, let me remove this part and that part. Okay, so using this formula we can actually derive the equation for that can actually be useful whenever we're studying an ellipse. So f1 to p, the formula of distance is very known to us, x2 minus x1 squared plus y2 minus y1 squared, of course the square root of that. So for f1 we've got negative c as our x, so say negative c minus, so against a point p, that's going to be x squared plus, for our y we have 0 there, minus y squared. So that's just as good as just writing y squared, right? 0 minus y, that's going to be as good as y squared. That's for the first part. Now remember, this is supposed to be the square root, right, when you're dealing with a distance. Okay, so that's for the first part, plus the other distance, p to f2, so our f2 is c for our x, so c minus x squared plus y minus 0 again, 0 minus y, which will still be y squared. Okay, so we've got a square root there, then this is equal to a constant 2m. Okay, So I can actually show you how the equation comes about, just in case they ask you. Okay, so my goal is actually to show you how you come up with formulas for all the 4 conic sections. So let me show you how we can actually simplify this. So the principle is actually very simple. So you have to move one of them to the other side. Okay, so if we do that, what we're going to have is something like this. If one goes the other side, the sign changes, it becomes a negative, right? So let me move the whole thing. Okay, so that will now become a negative. So we're trying to solve a radical equation now. So you have to square both sides, find the square root of both sides. Okay, so on the left where we've got a single square root or radical, we're going to remain with what's in the brackets, squared. So negative c minus x squared plus y squared is equal to the other side 2a times 2a. That's going to give us 4a squared, and then 2a times that will come twice. Okay, so we're going to end up with negative 4a, and then the square root of c minus x squared plus y squared, and then if we multiply what's in the brackets by itself, it's going to give us a positive. Now we're going to have c minus x squared plus y squared. Okay, if you're okay, we can actually move on. So here we've got brackets, there we've got brackets. You just need to differentiate the c. So expanding what we have there, negative c times negative c is going to be positive c squared, and then negative c times negative x is going to be positive 6x. So that's going to come twice, so 2cx plus y squared equal to 4a squared minus 4a, and then under the square root we still have c minus x squared plus y squared. Okay, and then at the far end we can still expand what we have. So c minus x squared, we're going to have c times c, that will be c squared, and then that will be minus 2cx, and then that will be plus x squared, and then plus y squared. Of course, anything that is on the left and the right that we think we can actually subtract, okay, so we subtract things if they are of the same sign on opposite sides. So c squared and c squared are the same. If one goes the other side, they'll subtract. Then what else? Y squared as well. Okay, what's remaining at this point is we have 2cx is equal to 4a squared minus, so we have minus 2cx there plus x squared, and then the radical, which is minus 4a, and then the root of c minus x squared plus y squared. Okay, so let's think of a way that we can actually simplify this. Okay, these are like terms, right? So we're going to end up with 4cx on the left, and then on the right we still have this part. So 4a squared plus x squared minus 4a, the root of c minus x squared plus y squared. Okay, what can we do at this point to simplify this? Remember, our goal is we don't want to remain with any radical. We want all, since we've got one radical remaining on the right, we need to find ways and means of moving it away. Okay, so you can actually see that the 4 is common, except on the case of the x squared. So let me take us a little bit back. Okay, so at this point, now that we've squared both sides, we can go on and simplify. So the square root and the radical just cancel, so remain with negative c minus x squared plus y squared. This is equal to, now that we've squared the other side, we can't just cancel with the radical inside because we've got two things inside. So what that implies is we've got two brackets in that form, or having 2a minus square root of that again 2a. So we just have to perform normal multiplication. 2a times 2a is the first expression that comes. That's going to be 4a squared, and then 2a times that will be negative 2a of that, and then it will come back twice, so it's going to be negative 4a, and then the square root of c minus x squared plus y squared, and then when you multiply the radical by itself, you remain with what is underneath. So c minus x squared plus y squared, the radical just disappear, right? I believe you know that. Okay, now we can just try to simplify what we have a little bit. So we've got negative c minus x squared. Again, if you multiply negative c by negative c, you're going to end up with a c squared minus 2cx plus x squared, and then of course y squared equal to, we have 4a squared minus 4a, the square root of c minus x squared plus y squared, and then plus c minus x squared, which we can also expand, right? We can expand that. So c times c there is c squared, and then c times negative x is negative cx, and then negative x, so it will come twice, so negative 2cx plus x squared plus y squared. Okay, we can cancel out the things that are common on the left and the right. Of course, they should be the same sign, so that we kind of like subtract. So if you subtract from the left, we can see c squared minus c squared, it would disappear. What else? X squared, y squared, and y squared. Okay. At this point, I can group what's remaining. We've got negative 2cx on the left. We can collect the like terms. Well, is this supposed to be negative, this one? Negative c times negative c with positive c squared, and then, no, this is supposed to be positive. It's supposed to be positive, because negative c times negative x positive, again, yeah, positive. and then that one on the right will become positive as well as it gets to the left, and then we have 4a squared minus 4a square root of c minus x squared plus y squared. Okay, we can already see that we've got a common coefficient, right? Because if we had what's on the left, we're going to end up with 4cx. So at this point, if we divide by 4, we can divide by 4, and so if we divide by 4, what we're remaining with is cx on the left, and then a squared there, and then minus a, and then the root of c minus x squared plus y squared, right? Okay, so at this point we want to write it in a way that we can easily square both sides, because we want to do away with the radical on the right. So cx minus a squared, so that we just remain with the radical part on the right. Okay, so what do we do at this point? So we can square both sides. Okay, square both sides, and then you're going to end up with c squared x squared, and then if you multiply with the a, it's going to be minus, which is going to come twice, of course, so minus 2c x a squared, and then plus a to the power 4 equal to the other side, negative a times negative a will be a squared. In the brackets, we're just going to have what we have there, which we can actually just copy down. So c minus x squared plus y squared. So the radical has disappeared because we squared both sides. Okay, so what do we have? So we have c squared x squared minus 2cx a squared plus a to the power 4 is equal to, we can expand what we have inside the brackets. C minus x squared, that's going to be c squared minus 2cx plus x squared plus y squared. And so we have c squared x squared minus 2cx a squared plus a to the power 4 is equal to, if we distribute the a squared to what we have inside, we're going to have a squared c squared minus 2 cx a squared plus a squared x squared plus a squared y squared. Okay, so this part and that part are the same, and they're having the same sign. So if we add both sides by positive 2cx a squared, this part and that part will eliminate. Okay, so we can collect what we are remaining with. Okay, so let me pick the ones that are having the c squared and the c squared and the c squared. In fact, the parts that are having the x squared to be on one side. So let me maintain the a to the power 4 to be on the right, so f4, and then which other part is having the a squared? That part, because the idea here is I want to pick the parts that are having the x squared to be on one side, so this part and that part. So this part can go the other side to become minus a squared c squared is equal to, on the right I'm now going to have this part which is a squared x squared, now minus 2, not 2, minus c squared x squared, and then plus a squared y squared. Okay. If we are to factor out what we have, let's see what we're going to remain with. So for the first part, if we factor out a squared, we're going to remain with a to the power 2 minus c squared, and then our a squared outside. And then on the other side, if we factor out the x squared, we're going to remain with a squared minus c squared, and then divided by what? What is outside is x squared, which is common, and then we are remaining with a squared y squared. Okay. What do we do at this point? What can we do? Okay, so we can do something interesting to simplify what we have. What do you think we should do there? So we can divide by what we are seeing to be common, which is the a squared minus c squared, right? Okay, we can start by dividing by that. So we can divide by a squared minus c squared, even that side a squared minus c squared, and then a squared minus c squared. So for the first part and the second part, it's going to disappear, and then we can see we want to, so we're already having a 1 there. If we divide again by a squared on the next step, so a squared is equal to x squared plus a squared y squared over a squared minus c squared. We can do something funny again. We can try to divide again by our a squared. Okay, so a squared will divide, so we remain with a 1, and then x squared over a squared plus, that would divide again, so y squared over a squared minus c squared. If we exchange them, we'll have x squared over a squared plus y squared over a squared minus c squared equal to a 1. Now this is where you do something interesting. You can let now your b be equal to a squared minus c squared, and then now you know that your equation becomes, well, that's actually b squared, so equation becomes x squared over a squared plus y squared over b squared is equal to 1. Okay, so this is very simple. Okay, this is where the major axis is along the x-axis. So I like thinking of it in this way. The normal way is where it is along the x-axis, so follow the alphabetical order like this. Now the ellipse is going to carry a positive sign in the formula, and then when you talk about the hyperbola, you see that it's actually the opposite, right? The sign in between is focusing on the difference, so it's a negative sign. Okay, which is also in a case where it is along the x-axis, right? Okay, it's also equal to 1. Now it's a negative, it's a minus in between there. Now in a case where the ellipse is going to be along the y-axis, you swap again the y squared and the x squared, just like we did under the hyperbola. Okay, now the other thing that is different here is the b squared is different in that it's now a minus c. For the hyperbola it was c squared minus a squared, and don't mix these two up. Okay, I hope you've gotten the difference between the two. Okay, So now that I've shown you the formula, let me now proceed in the next video where I'm going to now look at an example. Okay, example questions.